Hello, C461. Today we're going to give you an example on the force method. For this example, you will draw the shear and moment diagrams for the above structure assuming C settles 2 inches. Now the first step in this process is to determine the degree of static indeterminacy. For this, you'll want to do this so that you can pick which redundant you'll need for the next few steps. After you do this step, step 2 is to transform the structure into a system of statically determinate structures by releasing the number of constraints equal to the degree of indeterminacy. We will want to use superposition as we will add in the loads from both the uniform load distributed across the top and the point load where the reaction will be. This will result in 2 deflected shapes, which will help give you another equation to solve for the reactions of your system. In the first simply supported beam, you will find the deflection due to the loading on the beam. In the next simply supported beam, you'll find the deflection assuming that the reaction point C. These will give us 2 deflection equations to relate to one another. So the next step you want to do is to write this equation, which you will need to solve. For this case, you'll say delta C is equal to delta C naught plus delta prime CC. So that will be the deflection that you're given, 2 inches, plus delta C naught, as you can see in the superposition equation above, and then CY FCC is what the deflection will be from that unit load where the reaction would be. To get these deflections, you'll want to use the front cover of your textbook to solve for delta C naught and FCC. Sometimes it is easier to leave these in terms of EI and wait to solve that until the end. In this case, we will show both. Also, you want to remember your sign. In the first case, we assumed the deflection was downward, so that came out to be a positive number. In the second case, since downward deflection is assumed to be our positive, then it will be a negative, since the 1 kip unit load at the support we are looking for goes upward. Now that we have those 2 values, we can go back and plug into our equation and solve for reaction CY. It is important to learn this method as it will be used in the field if you do go into structural engineering. An example of this is if you have a complicated structure and you need the reaction of, say, a crane system, if you're designing a building with a crane system, and you need those reactions to put on your structure to account for those loads. It's also, as this example shows, if you have a member that settles in part of it, it will have a great impact on the reactions from that settlement. As you can see, solving for CY, we get about 177 kips, but that's a negative number, and since we assumed it upwards, it actually acts downwards due to the settlement initially. Solving for BY, taking the moments about A, we assume that since CY is downward, assuming it counterclockwise as positive, that will be negative. BY times 20 will be counterclockwise, and then the distributed load will be downward, making a clockwise moment. This gives you BY equal to 108 kips. Next, you'll solve for AY using some of the forces in the Y direction, assuming that Y is positive. This will give you AY equal to 108 kips. Now these worked out to be the same because we have completely symmetric loading and a completely symmetric beam. Please note that this will not always be the case. Now we can finally draw our shear and moment diagrams by plotting the initial starting point and knowing we have a downward distributed load which reduces in a sloped linear line all the way down to 108 negative after you jump down from the reaction at CY. Now that those two lines slope down, you will get a parabolic function for the moment. Please learn how to do shear and moment diagrams, as they are very useful in steel design, and you will be tested over them in both steel and concrete, and you have to pass those to pass the class. And with that, that is how you use the force method. It is very useful in actual structural engineering, and we hope this example you're able to follow and help and learn from it. Thank you.